Hello everybody. Today I am going to be making these engines actually do something. Yay! Since I'll be using events and doing it in the exact same way that I said I would in the previous episode, I figured it would be worth showing you that. Now this isn't going to be a tutorial, this is going to be me live coding something, so it's going to be a little bit more scatterbrained, then I probably won't add it to the playlist, but it's a great example, I hope, of what you would do in order to use Unity events in a more complex way while still remaining easy and robust. So where do we stand? Well, we have some engines and they have some particle effects, and we also have a ship that can accelerate or decelerate according to a throttle. Now one option we have is that the throttle controls the engines. When you move the throttle open, the engines start to activate and fire. So now the engines would be firing at 50% all the time. We'd keep accelerating forever. But I want to do the opposite. I want the throttle to be our intended forward speed. And the reason for that is because the only time that you want to have an infinite thrust situation is when you're trying to accelerate towards a significant fraction of c, or trying to accelerate over long periods of time, or anything like that. We don't want that. Instead, the only time we're going to be really worrying about our maneuverability is when we're in close with other ships or situations, and we'll want to be able to have a lot of really precise control. An all or nothing situation where we have to try and figure out how fast we're drifting would make that very difficult. So we're going to have our throttle control our absolute speed rather than our acceleration. So a throttle at 50% means we would go at 50% of whatever our ship computers currently deem is safe. Because of that, we actually have to do a lot more complicated stuff. We can't just open the engines up to n%. We have to calculate how fast we're going as compared to how fast we want to go. So let's go over to the spaceship. Here it is. We have a couple of details here. Max target speed of 100, and that's what we're going to be using. So when we pop this up in our editor of choice, here it is. It's not a very complicated routine yet, but it's going to get more and more complicated as things go on. We do not need the wah event anymore. That was a demonstration that we're done with. Boom. We're going to, however, need another kind of event. We're going to be calculating out the vector 3 that we want to move at. Let's go ahead and calculate it out first. So here in update, we will do the calculation. We could do it in throttle percent change, except that as we rotate the ship, our intended vector is going to change. In addition, our intended vector may change depending on whether the player, is trying to strafe the ship. So we're going to go ahead and put it in update. Vector 3 intended velocity equals, and what do we want? We want transform.forward times our intended speed, which is the throttle percent times the max target speed. Now we also need our current velocity, and that's going to be our current rigid body. RB stands for rigid body velocity. Right? And so our delta. Now we can clean this up later if we don't like declaring all these variables, but I'm not real worried about it right now. The delta is, of course, the intended velocity minus the current velocity, and that is the amount of acceleration we need. So rather than calling it delta, let's call it acceleration required. That's our acceleration. Now what we want to do is we want to tell the engines that that's where we want to go, and the engines will be responsible for trying to get us there. So we're going to need a new kind of event, because we don't have a vector 3 event. We've only got a float event. Simple enough, we'll just make a vector 3 event. We can call it a vector 3 event or a vector event. I don't ever use any of the other kinds of vectors, so I'll make it a vector 3. And we're going to need to define it. Public vector event acceleration required. So there we are. This is a simple way for us to determine how much acceleration we need and then pass it to whoever is listening. Boom. Only problem is nobody is listening right now. So if we were to hit play, we wouldn't notice any changes at all because we haven't actually connected that to anything. So what we need to do is we need to have the engines automatically sign up for that event and automatically respond to that event. The engines, which are denoted by these red arrows and the 10,000 lights attached to them, are right here. thruster module. So let's go ahead and start with our catching function. Public virtual void acceleration required. Now this is going to be happening inside of someone else's update call. So just so you're aware, if we are going to pass something to our update call, we're going to have to play tiddlywinks with the update orders, or else we might be one frame behind. So we're going to want to try and keep all of our logic in acceleration required if we can. Let's go ahead and give it a shot. So we have a vector 3. We actually get past vector 3. And what we would like to do is determine how much acceleration we need to put on in order to reach it. One option is obviously just to flat out accelerate as hard as you can. But another option would be to steadily change the actual throttle, the local throttle. And we can actually use that to define a lot of complicated engines by having various kinds of response speeds. So you might have a big engine, but it only opens up slowly. You might have small engines that snap right open. So to that end, let's create a local thrust public float. I actually think that thrust might be it. Yeah, this thrust here was intended to be that, so let's go ahead and make it local throttle equals 0. There we are. So make sure that we didn't actually use that anywhere. Yeah, that's fine. And so now we've got this local throttle, and we're going to be setting it. So we're going to need to have an amount we can set it with. So public float local throttle speed equals 1. And we'll just go ahead and put in a tooltip. How many seconds it takes to open, close the throttle. Later on we might change that so that it includes like a different variable for opening versus closing and all sorts of other stuff, but that's fine. And this, speed implies higher is better, so this might be a local throttle delay as a better name, so that we know that if we increase it, it's worse. With that in mind, down here in acceleration required, what we actually want to do is determine whether or not we need any acceleration in the direction we're going. So to do that, what we need to do is find out where we're going as opposed to where the ship is going. So vector 3 heading equals transform.forward. Now let's go ahead and just stick out a debug. Debug.log heading plus verse plus a cell. And we're going to want to sign up for the ship. So here we actually get the ship here in Awake. So we'll just say ship.on acceleration required dot add listener, and then we add in our new listener of acceleration required. Nope. And then on destroy we get rid of it. Perfect. So now let's go ahead and just test and see whether or not the event is correctly set up. Yep. So you can see that when our throttle is raised, we declare that we want a different speed. Now if I were to clear these and start to bring our throttle down, you can see that the amount changes. It reduces and reduces and reduces. Now I'm not 100% sure the best approach there, but one of the things that's interfering with us is that we are currently setting the velocity right here. So we'll comment that out, and that should actually give us a better idea of what's going on, since it was really interfering with us before. There we are. Since we're not moving at all, you can see that any throttle is a forward vector. You can also see that we are actually facing backwards, and that's on purpose. If we were to look at the objects here, these red projections are facing forward from the engine. So that's the way our thrust is going to go, and it's going to push us towards the front of the ship. So we're actually going to see how much our negative forward vector aligns with our intended use. To do that, what we need to do is we need to flatten the two vectors and to see whether or not there is any sort of alignment between them. That said, at the moment, we're not going to have to worry about that because it's always going to be forward. We can't turn the ship yet and the engines can't rotate. So I'm going to skip the vector math just because I'll do that off screen. If you guys want me to do vector math on screen, I'll make like a lesson out of it. For now, we're just going to assume that the z coordinate is all that matters, and we're going to program it like that. So let's go ahead and get those z's. Float a cell along vector equals a cell.z times heading.z times -1. And this will get how much acceleration we want to go along the vector. And we can say if a cell along vector is greater than 0, then we want to lerp our throttle delay forward. So we have a couple of options here. I think that we can still get the time delay even though we're not in our update, because I think that the spaceship's update still counts. What am I talking about? Well, when you get called with update, you get a delta time. If I can remember, what is it? How do you get the delta time? Time.delta time? There it is. This gets set every time that update gets called. But we're not using our time.delta time. We're using the ship's time.delta time, which is a little bit weird, but I don't think it'll bite us. I think it'll be okay. So we're going to say local throttle plus equals, or actually we'll use lerp. Local throttle equals float.lerp. You don't have a float.lerp? Is it a math f.lerp? Yeah, there it is. And then we will go ahead and give it the local throttle, our target throttle, and the time.delta time. Now this isn't exactly what we want to do, as it means that we will not actually go to full open throttle very rapidly. It's going to slow us down, times divided by local throttle delay. We're actually going to take more than a second to open or close the throttle like this, but that's fine. We can polish it later if we like. Otherwise, we lerp towards 0. Sound good to you? I like it. So we have this local throttle, but we're not actually doing anything with it yet. So let's go ahead and just debug log the local throttle. But let's also go and use that local throttle as an actual method of thrust. Now, one thing we can do is we can put it here in acceleration required, except that later on I plan to optimize acceleration required so that it doesn't happen every frame. If the ship is traveling at the speed it wants to travel, I don't feel any impulse to keep updating everything. So what I want to do is I want the update up here to handle it. Now we've got some stuff here in the update, but these are all visuals. So this is particles and lights to reflect throttleness. Up here is the percentage of thrust, which is just the local throttle. In fact, I can delete percentage of thrust and put local throttle in everywhere. So we're still not accelerating at all, but let's see whether or not we get a good particle effect. Yep. That actually doesn't look right to me. It should be a lot more aggressive than that. Oh, I know why that is. I was multiplying it by 100 before when I was testing it. So we're actually going to go ahead and adjust the thrusters. All 6 of these thrusters, what used to be out of 100 has to be out of 1. So that means 10 and 2. Let's try that again. That has nothing to do with this lesson. There we are. So now you can see that as they open, we get a much snappier response, and we can get a visual on how hard they're pushing. Of course, they aren't actually pushing yet, so that's the next step. We're going to go in and make them push. We're going to do that here in Update so that their push will be applied every frame. Otherwise, it will only be applied when the spaceship decides that it needs to be moved, which is not quite right. So how do we do that? Well, there are a lot of ways to do this, but we are using a rigid body, so we might as well take the ship and just apply that force directly to the rigid body. Add force. We can also add force at position. If we add force at position, that will mean that the ship will tend to spin out of control a lot, and I'm going to just assume that your flight computer is going to make sure that all of your gimbals are working, and you're going to be moving forward as much as possible. I may put in something where if your center of mass is too far to the side, it does spin you, but for now we're going to make sure, we're just going to assume that that's not the case here. So we'll add force, and the force is going to be our we don't actually have a variable for it yet, so public float max thrust, and we're going to go ahead and set it equal to 1. Why not? So ship.rb.add force max thrust times time.delta time times local throttle. And we have to apply it as a vector 3, as you can see. So what we want to do is we want to multiply our forward vector by that and -1. So vector 3 dot forward times, sorry, it's transform dot forward, times max thrust times time to delta time times local throttle times -1. There we are. Otherwise we'll fly backwards. And then we have a couple of options here. We can tell it the force mode. We can tell it just the force mode. So I don't know what the force mode is. This is new. Force mode dot acceleration, force, impulse, velocity change. Well, we want either force or impulse. I'm not sure what the difference is, though. Add an instant force, impulse, add a continuous force. Is a continuous force processed every physics update? Let's try this. If we change this and put this down here, what we might actually end up with, down here, this continuous force might be a way for us to handle this without needing to do it every update. It would be on a physics update, which would be ideal. In fact, if we can't do it like this, we're going to have to put in a physics update call. Boom, hit play, see what happens. We are moving, but it's super slow. I think that 1 is probably too low. Let's go ahead and increase the max thrust from 1 to 100. Now this is obviously going to be more complex in the future. These things are attached to particle accelerators, and we would need to know how much juice the particle accelerator is putting out and all sorts of other stuff, but for now, this should be enough. Yeah, there we are. Now obviously we can't slow down, we have no control over that. The ship's rigid body is not planning to stop us anytime soon, so it'll just keep floating off into the distance forever. Ship. Yep, moving pretty fast. So if we were to just turn it on a little bit, let's see whether or not it peaks out and stops. Ah, look at that. Works fine. So I'm not 100% sure whether or not that force system works, but you can see how this works. Let me go over it one more time because I wanted to show you how easy this was to set up, and that was a pretty straightforward way to do it. In the future, it's going to get a lot more complex because we're going to have engines that can rotate and stuff like that, but all of that is planned out for because we are using the vectors rather than just a flat speed. So what we've got here is we've got a ship, and the ship knows what its throttle is set to. So the ship calculates out where it wants to go. Right now that's just forward at a specific amount, but if I were to use WSAD to tell the ship to strafe, then it might also add in various other directions. And of course it also understands, stop please, I want to go backwards, although we don't have any engines pointed that way at the moment. Might be fun to do it though. Let's go ahead and just test it out. Anyhow, the ship understands the velocity it wants to go as compared to the velocity it is going, and if there is a difference between the two, it will call an event which will tell the engines to change how they are currently firing. The thing is, though, that that engine event is just a Unity event. So we sign up for it like a C# event, and we unsign up for it when we die. But we can add other things here. If we want to, we can make it so that there is like a flight control computer that pops up on screen telling you the vector that you're trying to head and the acceleration that you need to go. We can add all sorts of other things into this on-acceleration required event. It doesn't have to just be the engines. The engines are automatically signing up for it, but it doesn't have to be that way. They're moving so fast that the particles are falling behind the ship. It kind of works. There's some overlap there that we'll have to be careful about, but in general that seems to be okay. The intent works. There's a lot of polishing that needs to still be done, but this event system is already on its way to working. If you were going to be doing prototypes, that is a pretty fast way to put the prototype together. So this is a flexible and powerful way to hook the ship up. Obviously, you could code this using other means. You could have the engines check to see what speed the ship wanted to go, or you could have the ship constantly tell all of its engines to go at different speeds. But I like the agent approach that I have here, the approach where the engines don't actually know anything, they're just being told what vector to fire on, and they know which vector they're pointing. That has a lot of flexibility to it. We can have other engines that rotate. We can have engines that respond differently depending on the kinds of vectors involved. There's a lot of options, and I like to keep my options open. Anyway, I hope that this was a clear example of how this works, and I hope I didn't bore you too much. It was, 20 minutes, which was shorter than I expected, actually. Sorry if I was nattering on too much. I've still got a lot of stuff to do with this. I've got to do some vector math, and I've got to make it so that they don't overlap and push into neutral too much. Got to make some engines that spin. Lots of work.